About 66 million years ago, an immense meteorite collided with Earth, unleashing enough energy to trigger one of the largest mass extinctions ever documented. This cataclysm marked the end of the dinosaurs, except for the birds, and ushered in an era of post-collision mysteries that are rarely detailed in paleontological studies. This knowledge gap spans approximately 5 million years after the catastrophic event, a period filled with intrigue, as mammals rose to prominence after the fall of the Jurassic Titans. Known as the Danian, this early Paleocene stage unfolded from 66 to 61.6 million years ago, immediately following the devastating meteorite impact. In contrast to the violence of the impact that altered the course of life on Earth, the planet exhibited a surprisingly stable picture during this interval, despite earlier events. The immediate disasters, including drastic climate changes and ash deposition, had relatively ephemeral effects, with most severe damage attenuating within a few decades. However, studies indicate an initial reduction in marine phytoplankton, leading to global warming in the following half-millennium. Nevertheless, the early Paleocene climate bore many similarities to that of the Cretaceous, maintaining subtropical to tropical conditions and allowing polar forests to thrive under temperate weather, a legacy of the previous period. Terrestrial life post-impact, however, differed radically from that of the Cretaceous. The KT extinction not only extinguished iconic species but also restricted the average size of living beings, notably those of larger size. Thus, the Danian was a world without giants, a reconstructed landscape reflected in the fossils of this era's early days. At a remarkable paleontological site in Colorado, evidence shows the transformations in the first millennia after the catastrophe. In the first 1,000 years, living beings still struggled to overcome adversity, with mammals not exceeding the size of a rodent. However, signs of a tenacious recovery were already visible, with moderately sized crocodiles and giant turtles becoming part of the fauna of the time, alongside amphibians, birds, and fish that either survived the worst effects or recovered rapidly. Some ecosystems, such as forests, suffered prolonged biological homogeneity, with ferns dominating for millennia. But over time, tree diversity expanded, and within 200,000 years in the Paleocene, forest biodiversity already showed remarkable recovery. Mammals, now unhindered by the presence of large dinosaurs, evolved to sizes 3 times larger than their late Cretaceous ancestors. 1 million years after the impact, the ecosystem was already pulsating with life, featuring mammals the size of small wolves in full expansion. While the findings from a specific location may not accurately represent the global situation in the early stages of the Paleocene, they provide valuable clues. It is widely accepted that, some millions of years after the asteroid impact, a myriad of distinct ecosystems had already established themselves around the globe. Tropical and foggy forests, extensive mangroves and swamps emerged, creating dense jungles, although savannas were still the exception. In these biomes, large herbivores had not yet made their presence felt, but a diverse range of beings, including snakes, lizards, birds, and mammals, did. Among mammals, multituberculates stood out not for scientific merit but for their prolific variety, filling the niches left by the rulers of the Cretaceous. With features similar to modern rodents, multituberculates, now extinct, left us a legacy of fossilized teeth that reveal an impressive dietary diversity. A notable example was T. neolobus, from the early Danian phase, a giant among its peers, weighing around 100 kilograms and roaming North America, standing out as one of the largest terrestrial animals of its era, rarely exceeding the size of a sheep. Exceptions to these moderate dimensions included predators like the ankylodon, one of the early large carnivores post-extinction, reaching the size of a bear. Although it may not impress by today's standards, this size was remarkable for the time. The behavioral dynamics of mammals also changed. They ceased to be nocturnal creatures, hiding from non-avian dinosaurs, and became more active during the day, without the threat of large reptiles. On the other hand, birds, despite suffering considerably from the KT extinction event, showed a rapid recovery in regions like Australia, where they re-established themselves with remarkable speed. The early Paleocene oceans, though similar in temperature to those of the Cretaceous, underwent significant changes in their fauna composition. With the extinction of mosasaurs and other large marine reptiles, fish, which had been scarce in the late Cretaceous due to the predominance of ammonites and cephalopods, found an almost empty ecosystem, conducive to their rapid expansion and subsequent dominance. This diversification of fish was so successful that they now represent a significant portion of vertebrate species. Alongside them, sharks and rays also experienced an increase in diversity, assuming ecologically significant roles in the early Paleocene. As for the possibility of ammonites persisting into the Paleocene, this hypothesis remains a topic of debate and curiosity regarding the continuity of life from the Cretaceous to the Paleocene, even if it was for a brief transitional period.